All right, good afternoon. We are going to look now at finding the equation of a straight line using point slope form instead of the form y equals mx plus b that we looked at in our last lesson. So what we will use is here, m is y minus y1 over x minus x1. This will give you the equation of the line with slope m and passing through the point x1, y1. So this particular equation has much greater span than y equals mx plus b. Both forms require you to have the slope m, but this form of the equation allows you to use any point on the line at all, whereas the form y equals mx plus b requires you to know the y-intercept. Remember, that's the very specific point 0, b, where the line crosses the y-axis. So again, in order to use this equation, you need the slope m and you need the coordinates of any one point on the line. Okay, so we're going to practice using this now by completing 6 examples together. So write the equation of each line described. In the first example, we have the point passes through the points 3, 5, and -1, 2. So let's solve that one together. So again, the line in question passes through the points 3, 5, and -1, 2. So remember, we need 2 things in order to use point slope form. We need any one point, so we can use either this point or this point. I figure I will use this one as my x1, y1. The only other thing we need is the slope of the line. And luckily, we're able to calculate the slope since we do have the 2 points. So I'll label this point x2, y2, and I'll calculate the slope as we saw in our last class by using the rise over the run in this form. Okay, so in this case, it's 2 subtract 5 over -1 subtract 3. So this is going to give us -3 over -4. And therefore, overall, the slope is +3/4. All right, so now I have what I need. I have x1, y1, and I have a slope of 3/4, so I simply need to substitute into point slope form, which is here. So we put the slope on the left side, that's 3 over 4. And now the y and x, of course, remain in here as the variables. So we do y minus y1, so y minus 5, over x minus x1, which is 3. Okay, so again, I simply substituted into this equation. The slope was 3/4, y1 was 5, and x1 was 3. And that gave us this. And in order to simplify here, we simply cross multiply. We can go this way first or this way first. It doesn't matter. So let's suppose I go this way. Then it's 3 times x minus 3 is 4 times y minus 5. We open this up using multiplication. And we put everything onto one side of the equation. 3x minus 4y And now it'll be negative 9 plus 20. So that will be plus 11 is equal to 0. So that's the equation in general form. 3x minus 4y plus 11 is 0. Okay, let's try a second example. So in the second example, we have an x-intercept of 5 and a y-intercept of negative 3. In fact, then, we do have 2 points given to us once again, just like we did in question 1. We need to know that if the x-intercept is 5, this corresponds to the point 5, 0. And if the y-intercept is negative 3, this will correspond to the point 0, negative 3. So in question 2, we once again have 2 points. The points are 5, 0 and 0, negative 3. So again, this is the x-intercept and the y-intercept. And so we're going to do the exact same steps in the solution. So let's go ahead and do them. We start by calculating slope using y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. So that looks like it will yield negative 3 over negative 5, making the overall fraction 3/5. And now we're all set. We've got the slope and the point x1, y1. We'll substitute into this form right here. And again, we'll be keeping the y and the x as the required variables, right? They show up in the final equation. So we put 3/5 on the left. And on the right, we write y minus y1, so y minus 0, over x minus x1, x minus 5. Okay, just like that. So take a look again. We put the slope of 3/5 here. We put the y1 value of 0 here and the x1 value of 5 here. And that got us to this form. And now we cross multiply. Suppose I go this way first. Then it's 5 times y minus 0 is 3 times x minus 5. 5y is 3x minus 15. And when everything comes to the left side, it would be 5y minus 3x plus 15 is 0. And that's it. And this would be the same as writing negative 3x plus 5y plus 15 is 0. So just reversing these terms. And also, it's the same straight line. Remember, if you have all three signs opposite. So negative 5y, positive 3x, negative 15 is 0 would also be correct. Okay, so those two questions both provided us with 2 points on the line. So let's read our third one now. In example 3, what do we have? The line has a y-intercept of negative 5. So we know right away that that corresponds to the point 0, negative 5. And therefore, that can be our x1, y1. Okay? The line is perpendicular to y equals 3x minus 4. So hopefully this part here will provide us information about the slope because we need to know m. All right, so let's get started with this question. So again, first of all, in the problem they gave us, the y-intercept is -5. So that corresponds to this point right away. Now we know both x1 and y1. Okay, so in addition, our line is perpendicular to y equals 3x minus 4. Okay, so now we have to remember what we learned about perpendicular lines in our last lesson. If the lines are perpendicular, then the product of their slopes is equal to -1. So slope 1 multiplied by slope 2 is -1 if line 1 and line 2 are perpendicular. Okay, what is the slope of this line? Well, you can compare it to y equals mx plus b. So the slope of this line is 3 because 3 is the coefficient of x. Y is properly isolated. So the slope of this line right here is the slope of this line. Okay? So why don't we call this M1? M1 is 3. Okay? So our line, therefore, is going to have a slope M2 equal to -1 over M1. So M2 is -1 divided by M1. If we arrange this formula to solve for M2, we get -1 divided by M1. So that means the slope of the line we're interested in is -1/3. Okay, and remember, to figure out the slope of this line, all we did was compare it with y equals mx plus b. Okay, so now we have everything we need. We have an x1, y1 point and a slope to use in our equation. So we're going to substitute into point slope form. So the slope of -1/3 will be on the left side, and then we will write y minus y1 over x minus x1 on the right side. Okay, so again, -1/3 here, y1 is -5, x1 is 0. So we set it up just like this. And now it's time to cross multiply. I think I will first change this to y plus 5 over x minus 0. Okay, and now I'm going to cross multiply. So the negative will be kept with the numerator here. So we're going to use a positive 3 gets multiplied by the y plus 5, the equal sign. It is a -1 getting multiplied by x minus 0. Open up the brackets. 3y plus 15 is -1x. Everything to one side, and we'll have x plus 3y plus 15 is 0. And that's our answer. Right there. Okay, so here's a question. How would the solution be different if the word right here was parallel? Suppose we keep the same y-intercept, but our line is parallel to y equals 3x minus 4. What would be different? If it said parallel, we would use 3 as the slope right here. We would not use its negative reciprocal. but rather we'd have positive 3 over 1 here. Positive 3 over 1. And that would be the difference if the word was parallel. Okay, number 4. Our line passes through the point negative 4, 2 and is perpendicular to 2y minus 10x plus 6 is 0. So let's try this one. Okay, so the question is similar in that we're given a point. Now we're not given the y-intercept, we're given the point negative 4, 2. So we have x1 and we have y1. Our line is perpendicular to this one, 2y minus 10x plus 6 is 0. Now, remember here, we took the coefficient of x as the slope of this line. What's the trick here? Is this number negative 10 the slope of this line? No way. No way. Because first you have to make sure y is isolated. Here it was already isolated. So in this question we have to begin by isolating y. So first isolate 2y. 2y will be positive 10x minus 6. Now isolate y by dividing the whole right side by 2. You will get 5x minus 3. And now we are all set to compare this with the form y equals mx plus b. That tells us that 5 is the slope of the original line. So we'll call it M1 again to be consistent with this last problem. So slope 1 is 5. So slope 2 is equal to negative 1 divided by slope 1. And so it's negative 1/5. Okay, and so this is what we'll use in the left-hand side of our point-slope form equation. So these questions are very similar. The only difference was that here we had to first isolate y in order to determine the slope of the given line was 5. Whereas here y was already isolated and we could take 3 as the slope. All right, the rest of the question will proceed like this. We'll have negative 1/5 on the left side. Here we'll do y minus y1 over x minus x1. Like that. And then before I cross multiply, I'm going to change that denominator to x plus 4 because that'll make it a little easier. Like that. And now we're going to do the cross multiplication. So remember, this is negative 1 multiplying by x plus 4. It's a positive 5 multiplying by y minus 2. So when the fraction's negative, keep the negative sign with the numerator. So this is negative x minus 4 is 5y minus 10. If we put everything on the left, we'll have negative x minus 5y. And the constant will be negative 4 plus 10, or plus 6 is 0. And that's perfectly acceptable for the final answer. But the other correct way of writing this would be positive x, positive 5y, minus 6 is 0. Okay, let's take a look at question 5. So remember, we're going to just do 6 problems in total. question 5. So let's go to our page. Here we go. The line in question passes through the point 4, -1 with an angle of inclination of 22.8 degrees. What do we need? We need a point, x1, y1. Okay, so that's obviously given. And we need a slope. Hopefully this information will provide us with the slope. So let's try that. Okay, so we were given the point 4, -1, which means that we now know x1 is 4 and y1 is -1. The angle of inclination, theta, is 22.8 degrees. Can that provide us information about the slope? Absolutely. You might remember the formula from our last lesson. The slope is always the tangent of the angle of inclination. Okay, so you can use your calculator. Make sure you're in degrees. Tangent 22.8. That's the slope. Now, the problem is that this is not a very nice number to work with. We are going to have to round it. The angle has 1 decimal place, so we should use 3 significant digits for our slope here. And so that would be 0.420. So it is like that. So this leading 0 is not significant, but this trailing 0 is significant. It is to the right of the decimal. All right, so now we know what we're using for the slope, and then we're all set. We just set up the equation. It's a little awkward because we're going to have a decimal value here for the slope instead of a whole number or a fraction that we're accustomed to. Okay, so let's do that. We're gonna have this on the left for the slope, and then we write y minus y1 over x minus x1, like that. So before proceeding, I will change that numerator to y plus 1, like that. And then it's time to cross multiply. Now remember, whenever you had a whole number here, you could just pop a 1 under it to help keep things straight when you cross multiply. And the very same thing is true here. We can put a 1 under there, right? So in any direction we want to start. So here I'm going to take 1 and multiply it by y plus 1. And set that equal to 0.42 multiplied by x minus 4. Open the bracket using multiplication, both here and here. Minus, what is that, 1.68, I think. Put everything on one side. So it'll be y plus 0.420x. And the constant will be 1 plus 1.68. So it's plus 2.68 is equal to 0. Oh, sorry, this right here is minus. Do you see what I did wrong there? Good thing I caught it, eh? Usually in class, someone would let me know. Okay, so we have positive y. This term is negative when it comes to this side. The constant is 1 plus 1.68. So like this for our final answer. All right. Okay. You know what? I want to go back to just one thing before we do the last question, and it's this business of negative reciprocal. I want to make sure you're okay with it. In this case, the slope is a whole number, right? So it's -1/3. But I want to make sure you understand. For example, if the slope is equal to, here, I'll actually write. It's too hard to just talk, right? I've got an extra paper here, so let's do this. Let's suppose the slope is equal to -2/3. And M2 is perpendicular. So then M2 should be -1 divided by -2/3. And do you know how to work that out? That means the same thing as -1. You multiply by the reciprocal. Okay, but actually I'll just show you with the calculator maybe. But it does mean the same thing as -1 multiplied by -3/2. But I'll show you, right? You know how to use your fraction button? Have I showed you this before? So you can just do -1 divided by, and now you want to put in the fraction -2/3. -2/3. This button right here is for the over. Push equals. Okay, and this is the answer. It's +1 1/2. Okay, so that's correct. It's giving you a mixed fraction. But if you'd like to see it as an improper fraction, put shift and hit the button again, and you get +3/2. Okay, and certainly you could check. If I take -2/3 and multiply it by +3/2, I should get -1. -2/3 multiplied by +3/2, right, gives you -1. So that's just a quick example. Here's one more real quick before we resume. Let's say your fraction is 4/5. Okay, so that's the slope of line 1. If line 2 is perpendicular to it, its slope is -1/4/5, right? -1 divided by 4/5 is the same as -1 times 5/4. Okay, but you can do it with your calculator as well. So you can just do -1 divided by 4/5 equals, okay, so this says -1 1/4. That's true as the mixed fraction. Shift, hit the button again, and you get your improper fraction of -5/4. Okay, so just a quick example of using that property for perpendicular lines and how it would work if you had a fractional value here. Okay, again, we could confirm 4/5 multiplied by -5/4, see what it looks like, equals -1. Okay, enough of that, right? I'm sure maybe that was just a little too much. But anyway, let's do our last example. Question 6. Our straight line passes through the point 5, 2. So there we go, x1, y1. And it's parallel to the x-axis. Parallel to the x-axis. Can you picture that? I bet you can. Parallel to the x-axis. So what does the line look like? It's horizontal, isn't it? Okay, so you know what the slope is then. All right, so let's go ahead and try this. So question 6, we have the point 5, 2, and our line is parallel to the x-axis. Parallel to the x-axis. Okay, so here we go. x1, y1. So the x-axis is a horizontal line. So our line is also a horizontal line. And if it's a horizontal line, its slope is 0. So that's all there is to it. We're going to be putting 0 here, 0 here, 2 here, and 5 here. Okay, so that'll look like that. 0 is y minus 2 over x minus 5. Just like that. Now, you can just leave it 0, but again, if it's helpful to you, you can put a 1 under there and then you cross multiply. I'm going to go this way first. 1 times y minus 2 is 0 times x minus 5. Or y minus 2 is 0. And that's it. That's the equation in general form. And here's a very quick sketch, okay? Here is the x-axis. Here is the y-axis. Okay, the 0.52, I'm going to just say that that's here because this isn't graph paper. So that for me is the 0.52. So the line passes through the 0.52 and is parallel to the x-axis. So that means this right here is the line that we are describing with this equation. Y minus 2 is 0. And another common way to write that equation is like this. This is the line y equals 2. And further to that, so that question's done. But further to that, if you have a line instead that's parallel to the y-axis, okay, so I'm going to make one up here. It's completely different than question 6. Let's suppose we have a line parallel to the y-axis, and let's make it pass through the point -1, 3. I'm going to call the point right there -1, 3. Okay, so there's the point -1, 3. If we want a line parallel to the y-axis and passing through that point, remember, it's a vertical line, so its slope is undefined. And yet, we can still write its equation. What is constant for every point on the line here? Its x value is constant. In fact, its x value at all points is equal to -1. Okay, so this, for example, is the point -1, 0. This would be the point -1, -3, and so on. Okay, so this is the equation, x equals -1. So that's the equation of this vertical line here. You could also write it in general form, and it would be x plus 1 is 0. Okay, so I'll put that in a little box here just to make sure you're not confusing it with the solution to number 6. It's, I guess you can even call it a 7th example. It's the equation of a line. This is the equation of a line passing through the point -1, 3 and parallel to the y-axis. Or we could say perpendicular to the x-axis. Okay, that's it. We got through all of our examples. There are some problems for you to try in exercises 21.2. Okay, thanks a lot. Have a great day.